7 lanterns are hanging in the vertical line from a tall pole, connected to each other by ropes. Lantern 1 is attached directly to the pole at the top, and Lantern 7 is closest to the ground. At each time step, one of the remaining ropes is selected and cut. When a rope is cut, all lanterns below it fall and break. What is the expected number of cuts until only Lantern 1 remains? Let's look at this simulation. For the first cut, 2 lanterns fall. For the second cut, 2 lanterns fall again. For the third cut, only 1 lantern falls. And for the last cut, the remaining lantern falls. Now all lanterns have fallen except Lantern 1. And we needed 4 cuts. To solve this problem, let En be the expected number of cuts needed when there are n ropes remaining. So we have E0 equals to 0 and E1 equals to 1. When there are no ropes remaining, obviously we need no cuts. And when there is 1 rope remaining, we only need 1 cut. For n equals to 2, there is 1/2 probability of reducing to the case of n equals to 1, and 1/2 probability of reducing to the case of n equals to 0. Therefore, we have E2 equals to 1/2 E1 plus 1/2 E0 plus 1. We add 1 because we needed to cut the rope 1 time before reducing to the case of n equals to 0 or n equals to 1. Plugging in the numbers, we get E2 equals to 3/2. Now we repeat the same process for E3, E4, E5, and E6 iteratively. Finally, we get the answer of 49/20, or 2.45. As a follow-up question, can you find a general formula for the expected number of cuts when there are n ropes? Check out the answer at the link in the description.